Hey, Sander, how you doing?
Hey, Edwin. Yeah, I'm doing great. How are you?
Awesome, awesome. Yeah, summer vacation here, so
Summer
feeling great.
vacation. I'm almost out the door, leaving on my summer holiday. So
Ah,
just a couple
nice,
of days left.
cool. So we're gonna talk about Azure Container Apps, right?
Yep, we're gonna talk about Azure Container Apps, which is
Yeah,
a fairly recent addition to the Azure services.
yeah, and it's something. It has to do with containers, obviously, because it's in the name. But
Obviously.
is this, for instance, a competitor for AKS, something that we already had, Azure Container of Azure Kubernetes Services, I should say?
Yeah, that's a good question because, well, as you know, there are a lot of different ways to run containers on
Hmm.
Azure, right? So, in fact, I made a little slide for this one.
Okay, let's
So,
dive in then.
let's look at that one because,
Yeah.
yeah, AKS is one. Um, so, for instance, you mentioned AKS, which
Hmm.
is a really complex but really flexible system. But if you start at one of the more basic services, then you can think, for instance, about Azure Container Instances,
Yeah.
which is a service really geared towards running these single pod workloads, right? So you use this for basic workloads, but it's less suitable for running multi-container solutions because
Ah, yeah.
it doesn't have any of those really advanced features like auto-scaling or load balancing or traffic splitting, that kind of stuff.
Hmm.
Then you have, which I've used a couple of times for the different clients, of course, app services with web apps for containers.
Yeah.
So app services also gives you the possibility to deploy your web app inside a container. Now, this does give you more features than Azure Container Instances, but those features are mostly geared towards running web applications and are really less optimized for running distributed microservice applications.
Yeah, yeah,
So, if you're really into building microservice applications or other types of distributed applications, then of course you can look at Kubernetes, like you said. And AKS provides a managed Kubernetes environment, and it gives you many advanced options. And it also gives you a lot of flexibility because it's basically a complete Kubernetes deployment, right?
yeah.
But of course, that flexibility now also comes with a cost
Yeah.
because Kubernetes can also be pretty complex. Now, maybe I want to use many of the features that Kubernetes offers, but I don't need all of the features and all of that flexibility. So I would rather trade in some of the flexibility for simplicity and ease of
Yeah.
use. And that's the exact sweet spot where this new service fits in.
Yeah, that makes total sense. Yeah.
So with Azure Container Apps, it lets you run these containerized apps on a serverless platform, right? So you don't have to worry about the infrastructure. Now, talking about that infrastructure, it does use Kubernetes under the hood, but you do not directly interact with Kubernetes.
Ah, okay.
So
And
instead,
is
you can.
it actually built on top of the actual service in Azure then?
Oh, that's a good question. I'm not sure if they run a separate Kubernetes workload or they do run it on AKS. They probably run it on AKS.
Probably, yeah. Okay.
I would expect so. As we'll get into later, Azure Container Apps also has the ability to scale down to zero.
Hmm.
And it's a good possibility, I think, that they also use Azure Container Instances to deal with that and to create
Ah, yeah, yeah.
bursty scenarios.
Yeah.
Um, so instead of having that direct access to Kubernetes, it provides an abstraction layer, right? And that abstraction layer lets you deploy containers in a very simple way, as we'll see, but still provides some of those more advanced features like auto scaling, HTTPS,
Yeah, yeah.
Ingress, traffic routing, stuff like that.
Yeah. Cool.
So let's go ahead and see how this works.
Yeah, I'm curious.
So here's my Azure environment. Um, and so just so we don't have to wait on it, I've already created a container apps environment. Now, when you create this in the portal, it's actually pretty boring because there's not much to do here. You can see this environment has a static APIs assigned, but I've still got 0 apps right now. So let's fix that and let's go deploy an app to my environment. So we can do that in a couple of ways. So later on, I'll show you how to do it using ARM templates or Bicep, but we can also just use the Azure CLI. So there's this command, container app. And as you can see, it provides a lot of functionality to create apps, to deploy them, to look at the logs, to look at identity stuff, all sorts of things that you can do with the portal. You can also do through the AC CLI. So I've prepared a simple hello world container, which we can deploy now. So let me first start this commands because it takes a couple of seconds. So what I'm doing here is I'm executing AC container app create, right, which creates a new container app for me. So that container app needs a name, and I need to specify the resource group into which I want to deploy it. I also need to specify the name of the container environment where I'm going to deploy this. Then I give it the actual container image, which it will get from my Azure Container Registry. It needs some information about it registry, such as where is it, what's the username, what's the password. And because this is a really simple application that it just shows a web page with a message on it, I need to be able to reach that web page. So I want this to be callable from outside. So to do that, I need to specify the port that my application is listening on inside a container, which is port 5000. And then I need to specify that I want Ingress enabled so I can actually reach it. If I don't do this, I wouldn't be able to make a request to my application. So I specify that as external. And then finally, with this query, I tell it to please output the fully qualified domain name of that Ingress endpoint. So after that's done, you can see I've got this fully qualified domain name. It also already logged another message for me telling me where I can access my application. So let me just copy that, go back to my browser and type that in. And lo and behold, here's my awesome application, which just says, hello, container apps. Now, as you can see, this is served over HTTPS. And you get that by default. In fact, you get a redirect by default. So if I go to the HTTP endpoint, I will be automatically redirected to HTTPS, which is very nice, I think. Okay, so now if we go back to the environment in Azure, or in the Azure portal, and I refresh this page, then now we should see we've got a single container app deployed, which is my app Hello World. And if I click on this, I get all the details of the container app, including that application URL where I can reach it. Now, there are a couple of interesting things here in the sidebar. So first of all, there's this very nice turnkey authentication feature, similar to the one we have in app services. So let's say that I don't want everybody to be able to see this highly confidential message, right? I can add an identity provider. And let's keep it simple for now. Let's just choose Microsoft as the identity provider. I will let this wizard create a new app registration for me. And I will only support users that are in my single tenant. And I really want people only to be able to access my page if they can be authenticated. And when they're not unauthenticated, let's return a 302 response. So I just go by default, it adds a user read permission. I would just click on add. Oh, there's something I missed here. Oh, I did this before, and the app registration is trying to create that name already exists. So let's call this v2. A lot of app registrations to clean up later tonight. So let's click on add, and it will start adding that identity provider.
And Sander, now you are exposing these applications to the outside world, so also from I can reach it from outside of Azure. Mm-hmm. Is it also possible to keep it within Azure and only reachable by an internal VNet, an Azure VNet?
Yeah, I'll show you in a minute. So there are a couple of options there.
Cool.
All right, so that has succeeded. My authentication is enabled. So Now, when I refresh this page, you'll see, because this is the first time that I've logged in with my account, it requires consent, right? So let me just consent on behalf of my whole organization. And now I'm in. But now if I were to create a, let's say, create an in-private window, try to exit the page again, I will get this sign-in screen because it's now protected by that turnkey authentication feature.
Cool.
So I think that's very nice to have. Let's remove it for now, because otherwise it will get in the way for some other demos. So I'm going to delete this. Now, this is interesting because I've deleted my one and only identity provider, right? But because I added one, authentication is still enabled. So now the portal gives me this warning, hey, you've got authentication still enabled, but there are no identity providers. So basically, nobody can access your stuff. So would you like to remove the authentication as a whole? So yes, please do so. And we're back where we started. All right, so another thing. Let's see, what else do we have there? We have, you mentioned something about Ingress, right? So let's look at Ingress.
Yeah, I look at VNet integration.
Yeah, so there are a couple of options here. You can deploy a container environment inside your own VNet. So it's a bring your own VNet kind of feature, right?
Yeah.
And then if you want only other services that run inside that VNet to be able to access your applications, you can choose this limited to VNet option.
Yeah.
Which is grayed out at the moment because I didn't give it a VNet to work with.
Yeah.
If I only want other applications within my container app environment to be able to access my app, I would choose limit to container apps environment.
Yeah.
So typically what you would see if you deploy like a microservice applications, which consists of multiple services, only some of those services need to be exposed to the outside world, right?
Yeah.
You would set those to accept traffic from anywhere, and then the more backend service types you would limit to container apps environment.
Yeah, that makes sense.
And here's that target port again.
Yeah.
All right, so other interesting thing you can do, which I really like, you go to log stream, and you just have a really direct stream, real-time, up-to-date stream of your container logs.
Cool.
Which I also find very important to have quick access to. Everything is also logged inside a log analytics workspace. So if you want to do some Kusto queries on that logging, you can certainly do that. But I also think that having this separate, really lightweight view available is really nice to have.
Yeah.
All right, and then we get to a really important concept, which is revisions. So the Azure Container Apps application lifecycle revolves around this revision concept. And a revision is this immutable snapshot of a container app. And you automatically get a new revision whenever you create a new container app, like we just did, or when you make a revision scope change to an existing container app. So a revision scope change would be any change to your container configuration, such as the allotted amount of CPU or memory, or maybe you're changing the image. So any change to that type of configuration or a change in the scale rules is a revision scope change, and you will get a new revision.
Yeah.
Now, these revisions are very useful because multiple revisions can be active at the same time. So if you, just like we did, enable Ingress on your app, then you can now choose how you want to direct incoming traffic to those different revisions. And that way you can do stuff like A/B testing or blue-green deployments. And that's pretty easy to set up. So the first thing we need to do is, if you look in the toolbar, we can choose the revision mode. And currently it's set to single. So there's only one active revision at a time. So when I make a change, the current revision will become inactive, and the new revision will get all the traffic.
Yeah.
But I can change this to multiple. So let me do that. And now we just need to make sure we get a new revision. And to make sure that's something we can really see that it's a new one, let's make a change to our application. So here's the large amount of source code I've got for my application. And let's change it slightly. So let's say it's v2.
Yeah, this is so huge. I'm actually looking for unit test in your Project Explorer, but not yet, right?
That will increase the lines of code by a factor of 3 at least, I guess.
Probably.
Okay, so let's build this new image.
Yeah, now given in the label v2, so to indicate that this is the second version of this container image, right?
Oh yeah, good spot. So the previous label was called, I don't know actually. What did I call the previous label? I think I just used latest.
Okay.
But using latest is
tricky.
It's tricky to say the least, because whenever a revision restarts, it will always pull the image from the registry.
Okay.
So if you use latest, then depending on a revision restart and when you last push the latest, it may not be entirely clear which version you're using.
Mm-hmm.
So in the meantime, I try to push it to my Azure Container Registry, but it complains that authentication is required. Now, I did log in, but that was a couple of hours ago, so I really need to log in again. So let me get the username and password updated so that I'm sure those are up to date. Oh, picked the wrong one. I meant to do a Docker push. All right, so now we've got our v2 up in the container registry. So now how are we going to create this new, or how to push this image? Well, I'm going to use the Azure CLI again.
Mm-hmm.
Let me execute this AZ container app update command. I give it, some of the same stuff as before, the name of my app, the resource group. And now after I scrolled up, you can see I specified this new image, which is the v2 of the image. And I also use this revision suffix, which I supply v2 to. Now, this is just some friendly human readable label that is appended to the revision, to the automatically generated revision number.
Okay.
Or it's not really a number, it's more like a
label
thingy.
Yeah.
Well, there's actually something called label. Let me just show you in the portal. It will make more sense there. First of all, I can actually show you here, I think, by doing Azure Container App Revision List. Yeah, here we are. Okay, so here we have the top row is my first revision, right? And that's still getting all of the traffic.
Yeah.
So we deployed that around 12 minutes ago. And this part of the revision name is auto-generated.
Okay.
But it's completely random. So if you want to have something useful there, you can use that revision suffix to make it clear to you what this revision is all about.
Yeah.
So now I've added this second revision, but it's getting none of the traffic. So if I go back to my application and I refresh a couple of times, so this refresh is taking a little bit of time because I've changed the identity settings. But you see, everything is going to the old version.
Yeah.
Now, if I refresh my portal, I can also see those same revisions here, and this is why I told you it's not really a label, because I do have, in fact, this additional label field, which I can also use to make it clear what's what.
Yeah.
But let's say we want an even split between these two versions, right? So I'm going to do this 50-50. Let's save that.
And then the Ingress basically works as a load balancer between these two different revisions.
Yeah, exactly.
Cool.
So now if I refresh, about half the time I will get v2, and the other half I will get the original one.
Nice.
Which is really powerful, right? Because of course you can do all of this stuff in AKS, but you need to specify that in your manifest files, and well, you need a bit more knowledge of Kubernetes to get it up and running. Whereas we're just going through the portal or some simple ACCLI commands, this is really easy and quick to set up.
Yeah, that makes sense.
So let's switch gears a bit and have a look at another very nice feature, which is auto-scaling. So auto-scaling in Azure Container Apps uses KEDA. I don't know if you've heard about KEDA yet. So KEDA is this open source Kubernetes event-driven autoscaler, right?
Yeah.
So you scale containers based on the number of events that need to be processed. And what I already mentioned, but what I really like about Azure Container Apps is that you can scale all the way down to 0. So if there's no work to be done, you won't get billed for that. So let's show you this in practice. So let's go back to Visual Studio Code. Let's clean up a bit. And let's look at this template, this ARM template I've got here. So this is a template to create a second container app. And that container app is going to host my LoadGen program, which you can see here, which is really simple. It takes a connection string for a storage account, the name of a queue, the number of messages it should generate, and then it uses this parallel for each just to generate a bunch of messages and put them on that queue. Or actually, I'm explaining this slightly wrong. My queue JSON is my template for the container app, which is going to contain my queue reader.
Okay.
And the code I just showed you, I'm going to run locally to generate a load, right? This makes a lot more sense. So if we look at the, or let me just start the deployment so it can run while we scroll through it. So I'm just going to use a regular AC deployment group create to deploy that ARM template. So I've got a couple of parameters, the location where I want to deploy to, the name of the container app environment, and the storage connection for the storage queue. And then you need to specify a resource of type Microsoft App Container Apps. And with this managed environment ID, I link it to the environment in which I wanted to run. And now you can see some stuff that we've already seen. So the active revisions mode, you could choose between single and multiple, remember? So we set that to single, which makes sense because it's a backend queue processor thingy, right? So you want to know which one is executing it. And you may have multiple replicas, but you have one version of your code which is processing those messages.
Yeah, that makes sense.
So we can take the queue connection and put it safely in a secret. And then here we have our container configuration, which consists of the image and a couple of environment variables. So I've got the name of the queue and environment variable, and also the connection string. And here instead of setting directly a value, I reference that secret. So Azure Container Apps has this built-in feature for managing secrets for these types of scenarios.
Okay. I also saw a Dapr icon just now in the portal. Is this also supported by Dapr, or is it a completely different topic yet?
No, wait. Well, it's a slightly different topic, but one that we will get to. So, let's talk about Dapr a little bit later on because the combination is really interesting.
Cool.
The interesting part here in this template is the scale part. So here I'm telling it I want at least one replica and at most 10 replicas. And decide on the exact number based on these rules, right? So I have a Azure queue, which is a rule, which is one of the scalars available from KEDA. I can point it to my test queue, and I tell it that every time you see it being larger than 10, go ahead and scale up, basically.
Yeah.
Now, that doesn't mean it will immediately, if you put 1,000 messages in, it will immediately scale up to 10, because there are waiting times and like warm up and cool down times in it, just so it doesn't ping pong between the min and the max. But when we put enough messages in the queue, we will start seeing it starting to auto scale.
And all that stuff is configurable, I assume, in Kida.
Yeah. Well, you can. There are a lot of options here based on this scalar type. These
you have certain
fields will be different,
options.
right?
Yeah. That makes sense.
Yeah. Okay, so let's go to this loadgen tool. See if it builds first of all. Hope it does. And then run it, and let's give it something to work with. Let's give it like 1 million messages. It will take a while. And let's switch back to the portal and see what happens. So if I go all the way back to my container app environment, refresh that again, it should now show me 2 container apps.
Yeah.
Which is my hello world and my queue reader. So if I now go to queue reader and go to that very nice streaming log, you will see it's quite busy at the moment.
Yep.
And if you want to know what's it doing with the replicas, we can go to the metrics and then select the replica count metric. And you can see, well, interesting metric. So this is my test from this afternoon, right? While I was preparing for this demo. So you can see it scaled up all the way to 10.
Yeah.
And then went down. It stayed at 1 for a while. And then I guess I simply deleted it at that point, and it went to 0.
Yeah.
Now we're at 1 again. So if we now wait for a little bit, we should start seeing this go up again.
Yeah, because the minimum count, replica count, was 1, right? So it should never go down to 0 now.
Right. So wherever you see 0 here, it wasn't deployed at all.
Yeah, that makes sense.
And I'm using the same names for these container apps, which is why you see the previous the previous metrics. So let's see if it's already scaled up. Yep. So right now we're at 10. Oh, so that went actually pretty fast. So I'm not sure what the current Kida settings are. There's a possibility it will, well, actually it's scaled down pretty fast here too. So I'm not sure about those timeouts, but I know they're configurable at least. But you can see this outscaling is really, again, really simple to set up. You know, just specify your minimum, your maximum, and you're off to the races.
And if you go back to this log stream, because that was what I was curious about, can you also see the logs for the individual replicas?
I guess you can. Yep. Yeah. Well, you have to guess which one's which, of course.
Sure.
But yeah, you know, I guess it's pretty interesting for some workloads, you know, to see if they are balanced well. I could imagine a message processor working with poison messages and restarting all the time while other replicas are working fine.
Nice.
So yeah, so that's pretty useful. All right, so you've already mentioned Dapr, right?
Sure.
And up to now, these have been some more small-scale demos, but let's look at a bit more real-world scenario. Because container apps is really where I think it really shines is hosting microservice applications. Because for the really simple stuff, you've got Azure Container instances. You can use a web app for containers. But now I want to build something larger, something more complex. And that's also the point at which Dapr becomes more interesting. So Dapr, for those who are unfamiliar with it, let me open the website. This is basically a set of APIs to help you create microservice applications, or more generally distributed applications. So these APIs are things like state management or publish subscribe or dealing with secrets or calling other services, but having automatic retries and transport security and stuff like that. So stuff that you need to solve for your microservice applications, but you don't want to solve it. You just want to build your application. Dapr can help you with all these nitty-gritty details. And the interesting thing is that Dapr runs in a sidecar container next to your application container. So when you invoke a Dapr API, you can do that simply by making an HTTP call to that sidecar container. So you don't need to include a Dapr library or Dapr source code. So Dapr itself is written in Go, but your application can be written in any language. Just make sure you can make an HTTP call, which basically every language can. Now, Container Apps has native built-in support for Dapr. So it can automatically inject those Dapr sidecars into your application, which is really nice. And well, as you know, Edwin, when we were writing the Dapr for .NET developers ebook, we've ported eShop on containers, which is a classic .NET reference application, over to Dapr. And the result of that is on the .NET architecture side in this eShop on Dapr repository. And here you can see the resulting architecture. But the nice thing is that this repository now also contains scripts to deploy eShop on Dapr on Azure Container Apps. So this link isn't working exactly, but if you scroll down, you can see that all you have to do is, create a resource group and then just deploy this main.bicep file.
Yeah, and eShop is also the typical application that you want to run in container apps, right? It has some backend services, it has a front end, it does some queuing and stuff. So it's actually a really cool sample application to demonstrate this.
Yes, exactly. I think it's a really great fit for container apps. Now I've already deployed it, so let's go back. Well, I know why my portal is crashed, but let's go back to the Azure portal and to a different resource group, my eShop on container apps. So just deploying that main bicep file, deployed all of this stuff. Let me put this in. So we have, what do we have here? We have our container apps environment. We've got a couple of container apps. And just like you said, Edwin, some of these are really backend and are not accessible outside the environment. Some of them are accessible. We have some SQL database. We've got a service bus. We've got Azure Cosmos DB to store some state. So it's a pretty interesting application. Now, if we go to our UI, which displays a client, and we can click on the application URL, we will see our nice UI here. There we are. We can log in. I'm logged in as Bob, and I've got one thing in my shopping basket. So this works pretty well. Now, let's see what needs to be done to actually get Dapr to work in a microservice application. So let's go back to Visual Studio Code for a bit and have a look at that main bicep file, which deploys the whole thing. So I need to change environments because I need to go to a different repository. So I believe call it eShop on Dapr. Not on containers, that's the original one. All right, so here's the source code for eShop on Dapr, and here is that main.bicep file. So if you look at this file, you see a lot of modules to, well, first of all, deploy the container apps environment, then some infrastructure stuff, such as the Cosmos DB, the service bus, the SQL server. Down here, there's all the services, the identity, ordering, payment, all of that good stuff. Then here in the middle, we've got two Dapr components. And the scripts for those are pub_sub.bicep and statestore.bicep. So let's look at a statestore.bicep file. So what this does is it takes my container apps environment and it deploys a Dapr component into it. right? So this Dapr state store component is used to store the user's shopping basket.
Yeah.
Well, actually, that's its primary usage. It also stores some state for the ordering process.
Yeah.
So it's used by two different microservices.
Yeah. And you're using here the bicep existing keyword to make sure that this is deployed in the existing container apps environment, right?
Yeah, exactly. So I have, let me see, I think in infra, I have a bicep file to deploy a container apps environment.
Yeah.
For which I first need to deploy a log analytics workspace.
Exactly.
And then using that, I can create a container apps environment. So this is the resource to actually deploy it. And then later on, when I want to add to it, I, just like you said, I refer to the existing one. And
Based
now
on the
all
name.
of these nested resources get added to that one.
Cool.
And if you look at this component type, you can see I'm creating my state store of type state.azure.cosmosdb.
Yeah.
And of course, this is where Dapr really shines, because by using Dapr, my application code is now completely decoupled from Cosmos DB.
Exactly.
I don't have anything in my source code referencing Cosmos. I don't use the Cosmos DB SDK or even have to know any of the details of how to integrate with Cosmos DB.
No. You only use the state store API from Dapr.
Exactly. I just make those calls to the Dapr sidecar, which is a really simple API. And then Dapr will use Cosmos DB as the underlying backing store. And I can very easily change that. Let's say I want to use table storage. I just use the state.azure.table storage component. And it's I've switched stores, which is really nice if you know, for one thing, for future portability, but also if you run this in different environments. Let's say I want to use a different state store for local development or test environment separate from my production environment.
Yeah, makes sense.
So let me see. The rest of this file is basically, this is not a talk really going in depth in Dapr, but this is stuff that you would expect in a Dapr component file. You have this metadata with all of the settings and configuration that the state store needs to know about to be able to run. And by setting these scopes, I can specify which container apps are allowed to use this component.
Yeah.
So only the container apps which have the Dapr identifier set to basket API or ordering API will actually see and load and be able to use this this component.
Cool.
So let's go to the basket API and see how it is injected with Dapr, because this is a container app. It has some of the stuff we've already seen, like a name and an image and some environment variables, which we also saw with the queue reader. This time, no auto-scaling and just keeping it to one replica. But now I also have this Dapr section here. And by telling it to be enabled, Azure Container Apps will automatically inject that Dapr sidecar in my application. And that sidecar needs to know at which port my application is running, because I need to be able to communicate with each other. So that's what I specify with app port. And it also needs to have a unique ID, which I set to basket API in this case. So that's all the bicep I want to show you. Let's go back to the portal and look at the basket API here. So let's go to that container app. So first of all, let's go to this Dapr. So now you see that, hey, it's enabled. Well, we know that because we just seen it in the bicep. But here are the settings as visualized in the portal. You can also see it has both of these components because it's allowed to see them both. Now, what's also pretty interesting is I've talked about Dapr running in a sidecar container, right? But if I go to containers, you only see the basket API.
Okay.
Right? Because this is like a bit of a logical view of your application. So logically, you've only deployed your basket API container. And that Dapr sidecar is just an implementation detail. So you don't see it in this view. But again, if you go to the log stream, here you do see that there's a Dapr daemon container running.
Yeah.
So here I can go to Dapr, and it will show me all of the Dapr logging. Which is very nice because this is important logging. But pretty often, if you make any mistakes in the configuration, the Dapr logging will tell you so. So it's really useful to have this lightweight access to that logging.
Yeah.
So so there's not that much more to tell about this application. You can add stuff, and you can go to the basket. You can remove stuff. You can check out, and all of this uses Dapr to talk to Azure Cosmos DB and to Azure Service Bus for PubSub between services.
Cool.
If you want to try this out yourself, we'll add a link to the repository. It's I think it's a nice way to get started with container apps yourself, because it's a sample that has a little bit of everything. So Edwin, that's basically my quick overview of container apps.
Yeah, pretty cool stuff. One question on the Dapr stuff, though. Is it true that Dapr is actually, because it's completely open source now, right? It's a CSCF project. I heard rumors that Dapr is actually supported by Microsoft as used in Azure Container Apps. Is that true? So if you run into any problems with the Dapr stuff, you actually get support from Microsoft?
Yeah, that should be a benefit of having Azure Container Apps, because Dapr being an open source project, you're basically on your own, or you have to hire some outside consultants who hopefully know more about Dapr than you do. But then, if you use Azure Container Apps, it's a managed service. So if there's some stuff not working, you could just send your tickets to the ACA team. Yeah.
Cool. Well, great overview that you just showed us about Azure Container Apps. I really see the sweet spot that you were talking about. If you have a distributed application and you don't want to have all the bells, you don't need all the bells and whistles of AKS, but you also don't need the hassle of setting it up yourself, then you can pretty much be up and running pretty fast if you use Azure Container Apps. So yeah, great. I think it's a great addition to the Azure services.
Yeah, there's a real sweet spot for organizations that do want a lot of those nice advanced features, but are just not ready for or cannot justify a full Kubernetes deployment.
Exactly. Yeah, and going down to 0 instances, right? If you have a really bursty workloads and in the easy time frames, you can just go down to 0. Also, cost-wise, it's an interesting choice. So
definitely.
Okay, so thanks for showing us. I hope everyone at home watching also liked it. If you like dotnetFlix, please subscribe to the channel. And we hope to see you at the next episode of dotnetFlix. Have a good one.
Bye-bye.